what this price elasticity of demand less than 1 means. So from our previous discussion, we know that a good for which the price elasticity of demand is less than 1 is a good such as insulin. Right? It's a good that you desperately need, that you really do not care about the price. So if you are selling insulin, do you really want to cut your price to raise revenue? The answer based on our mathematical analysis is no. Because it really doesn't make any sense. You already know that you have a customer base who are always going to buy your good. So there is no reason for you to cut price to try to attract new customers. Because if you cut price, people who doesn't have diabetes are not going to buy your medication. Are we all clear on that? So for a good for which the demand is inelastic, it doesn't make sense to cut price to try to raise revenue. But if on the other hand, the good has very high price elasticity, okay, so a good for which the consumers are very responsive to price changes, so this was like a luxury cruise drive or an expensive car, you know that it makes sense for you to give price discounts, and that's exactly why you get so many price discounts on luxury cruise ride. Because our analysis shows that for goods for which you have very high price elasticity, a small cut in price raises quantity demanded by a large amount, and it can raise your total revenue. Okay? I can assure you that these are going to be in your exam. So it is very important that we, if you have any question, you ask me right now. Any question? Does it make sense? Does it make sense that total revenue and elasticity are intrinsically connected? If your demand is inelastic, cutting price reduces total revenue. If your demand is elastic, cutting price really raises your total revenue. Let's now look at this idea from a more graphical perspective. And I really am not in favor of looking at this from a graphical perspective, but different people look at it, look at these problems different ways. So I guess some people might benefit visualizing this problem. So let's do it. The same problem, the same intuition now from a graphical perspective. So imagine that the original price was $4 and your original quantity demanded was 1,000. Now you suddenly reduce the price to $3.70 and your quantity demanded increases to 1,050. Very simple thought experiment. You cut price, your total revenue goes up. You cut price, your quantity demanded goes up. Now the question that we want to now understand is that as a result of a price cut from $4 to $3.70, our quantity demanded has indeed gone up, but does that mean that our total revenue has gone up? Because that would give us the confidence to cut a price. Let us now try to think about what is happening when we are cutting price. What are we losing and what are we gaining? First of all, notice that when the price was at $4, the quantity demanded was 1,000, and suddenly when you cut price, you lose 30 cents on every unit that you were selling before. Are we all clear on that? If you cut price from $4 to $3.70, you lose 37 cents on every item that you were selling before. So by cutting price, this is the loss of revenue. The area indicated by the shaded area is the loss of revenue as a result of this price cut, which actually is 30 cents times 1,000, $300. That's the loss, revenue loss by cutting the price. then there is a revenue gain. Why? Because by cutting price, you are now able to sell more, right? How much are you able to sell more? You are able to sell 50 more units. And these 50 units, each of them costs about $3.70. That is the extra revenue that you have just generated for yourself. So the extra revenue is $50 extra unit times the price at which you are selling them, which is $3.70. Okay? If you do the calculation, you will see that this is $185. So $300 is your loss of revenue, $185 is your gain in revenue. So by cutting price, you lose $300, you gain $185. Are you really gaining anything? Is your total revenue really going up? It should not. It is not, right? You lose more than what you gain, right? As a result, your total revenue really is going down. Why is it going down? It is going down because when you calculate the price elasticity of demand for this particular demand curve, the price elasticity of demand is percentage change in quantity demanded divided by percentage change in price, which we did before in the last class. And the elasticity of demand was less than 1. In this case, since the price elasticity of demand was less than 1, cutting price did not generate enough quantity demand increase. As a result, your total revenue went down. The most important aspect of this discussion is that we really need to have very good intuition about how we look at these demand curves. Right? When you look at this demand curve, without doing all this calculation, your first intuition should be that this demand curve is kind of inelastic. It's kind of steep, right? You all see that? And that is where the intuition starts. And you know that when your demand curve is steep, it's an inelastic demand curve, and cutting price on this good is a bad idea. Make sense? If raising total revenue is your objective. Because sometimes your objectives could be different. Sometimes you might be foolish enough to just think about selling more. Something that we're going to look at the very later part of this course. Okay? So that's our total revenue concept. This is a very, very important concept. Please, so again, so the next situation is again the second part of this experiment where you are again doing the same price cut from $4 to $3.70. The loss of revenue is $300. But now notice that this demand curve is kind of elastic. It's a flatter demand curve, right? How do you know? Because now the change in quantity demanded is much larger. Do we all say that? It's about 200 units. And for this 200 unit, the gain in total revenue is now 200 times $3.70, and that actually is $700, and that is your gain in revenue. You should see clearly that now the loss of revenue is 300, gain of revenue is 740, so you are gaining more by cutting tax, by cutting the price, than you are losing. So overall, your net gain in total revenue is positive, meaning that your total revenue is going up. Why is this happening? Because based on our calculation from the last class, we know that the elasticity of demand in this demand curve is less than 1. It's more than 1. I apologize. The elasticity of demand in this case is more than 1. The absolute value of the price elasticity of demand is greater than 1. This is an elastic demand curve. So what we have just covered in our Word document is consistent with our graphical intuition. In summary, if your demand curve is inelastic, you should never cut price. If your demand curve is elastic, you should always cut price to raise total revenue. So the question is, what should you do if you want to really raise your total revenue when your demand curve is price inelastic? So with a steep demand curve, what would be the simplest way to raise total revenue?
Raise your price.
Raise your price. Makes sense. Remember, we started with the argument that there are two ways a firm can raise their total revenue. It can cut price, so that total revenue goes so that for the quantity demand it goes up, and it goes up so large that total revenue goes up. The other option would be to raise price so that quantity demanded does go down, but it doesn't go down enough, so that total revenue goes up at the end. So for an inelastic demand, your consumers are very price insensitive. Whenever price is cut, they don't really care. So if you raise price, your consumers are really not going to be able to reduce their quantity demanded. So by raising price for an inelastic good, you are going to be able to raise your total revenue. And that is unfortunately a very, very true phenomenon that is happening right now. I think if I did not mention that in the last class, but I think I did in one of the previous class, that the cost of prescription drugs have quadrupled in the last couple of years. Which means that slowly and surely the price of the prescription drugs that we buy from Walgreens and CVS are creeping up. How can a company systematically raise their price without losing customers? The answer is the price elasticity of demand is less than 1. They're very, very price inelastic. And the companies are doing research on that. They know that their demand is price inelastic, so they are taking the bold decision of raising price so that they are not losing enough customers and their revenue is going up. Yes.
So generally speaking, we generally don't think of education as being an inelastic good, but yet over the past 30 years, the price of education has risen 1,100 and something %.
Right.
So would that then indicate that education has become an inelastic good?
I don't know. That's a very good question, by the way. We, from a policy making perspective, are dealing with the same problem. And the problem is not a simple one. Your question is a very well designed question. I really am glad that you raised this question. We really don't have a concrete answer at this point, because education is kind of complicated. Education is a public good. It's not a private good, at least the education that you are receiving. You might think that you are paying about $55,000 per year for your education. It's not entirely true. Part of your education, part of the cost of your education is paid by the government. The federal government pays about 50% of your cost of education. So the question is, how come? Does that mean that every year the cost of your education is about $100,000? It actually is. And the question is, how come? I mean, why are we? So you might ask yourself, if I am really paying $55,000 from my pocket and the government is paying somewhere close to that, where are all this money? Right? Why are we still taking class in this small room where a lot of people are taking class? We should be having large beds where we could sit and sleep and take our classes. There should be a lot more technological assistance, or I don't know. It's a very difficult question, right? Part of the cost of your education is spread out over a lot of different factors, like research, like infrastructures. You can see that this has been fixed within 5 days, right? This is working now. This is amazing. If this was a private firm, it would take a month to fix this, right? That's where a major part of your cost of education is going. So we really don't know. We would like to believe that the demand for education is in a price inelastic. Otherwise, you would not be seeing enrollment going up at the same time tuition fees are going up, right? This is the only way this could be true is if the demand for education is price inelastic. And that's a good thing, right? You want your education to be a price inelastic good. We don't have enough tools to answer your question properly. I hope that some of you end up taking more rigorous course such as public economics or public finance, which is a course that you will take after you take intermediate microeconomics, where you will have enough tools to really at least address this kind of questions. But anywhere, a discussion about whether government should raise, or whether a firm should raise revenue, or a government should cut taxes or provide subsidy, will always start with a measurement of elasticity. Either you know it or not. So elasticity is a very important micro concept, which is widely used almost everywhere. So what we just did was to look at the effect of elasticity and how it affects the total revenue of a firm, and thereby affects the most critical decision-making process of a firm, whether to cut price or whether to raise price. So by now you should convince yourself that elasticity is kind of important. What we will do now is look at least within the given time that we have today, introduce you to two other measurement of elasticity. We hope to finish this chapter by Friday, and I'm going to post another quiz, another homework on this chapter. This is a very lengthy chapter. One of you send me an email asking about what we are going to do about the exam next week, which is going to be on next Friday. I want to keep the exam date intact because changing exam date creates a lot of problems. Okay? Just like exam number 1, we will cover everything that we have covered after exam 1 and have that included in exam 2. So whatever we cover up to next Wednesday will be in your exam, which means this chapter, the chapter before, and another chapter that we are going to start on Friday and finish by Wednesday. So please, study along the days that we are covering these materials. You should be a little bit disciplined with what we are covering, and I think we'll be okay. The next one that I want to talk about is to show how these three concepts really matter. Okay? So we had three relationships. Elasticity of demand less than 1, cutting prices really reduces total revenue, elasticity of demand greater than 1, cutting prices raises total revenue, and elasticity of demand equal to 1, cutting prices really does not change our total revenue. Now we are going to ask a very dramatic question, and I want you to really understand the data first and then move on to the graphical interpretation. Let's imagine that these are some arbitrary artificial data. The data makes a lot of sense. Please stay with the data. We are going to see this table several times in this course. Data on some really basic information about price and quantity demanded. At different prices, we are looking at the level of quantity demanded of the firm. So when the price was $8, there was no quantity demanded. The price was so high that nobody was buying anything. When the price was 0, everybody, when the price is 0, nobody's quantity demanded is 16, but there is no revenue, right? Because even if people buy a lot, if you are not charging anything, you are not getting any total revenue. Between price being 7 to 1 for different prices, notice that you are getting different kind of revenue. But there is a pattern in these numbers. There is a pattern in these numbers. First of all, notice that when the price is going down from 7 to 6, this was a very high price, right? You know that 7 is a very high price, right? Because when the price was 8, people were not buying anything. So when the price is 7, the price is still high. When the price goes down, quantity demanded will go up. It goes up from 0 to 2. Your total revenue is now 14. When the price drops from 7 to 6, quantity demanded increases and your total revenue increases dramatically from 14 to 24. Do you all see that? So When price drops from 6 to 5, total revenue increases. 5 to 4, total revenue increases. 4 to 3, total revenue decreases. 3 to 2, total revenue decreases. 2 to 1, total revenue decreases. So there is a very interesting dynamics in terms of how price cut is changing the total revenue. Total revenue initially increases, then starts going down. Starts with 0, increases, reaches a maximum, and then goes down to 0 again. The maximum is found where the total revenue is about 32 when the price was 4. Do we all see that? How come? We are only changing prices, we are not changing demand curve. So we are staying on the same demand curve, and depending on different price range, your total revenue is fundamentally different. The trend in total revenue is fundamentally different. You can argue and you can see that between the range of price being 3 to, in the range of price between 7 and 4, total revenue is increasing. Between price of 3 to 0, total revenue is kind of going down. Isn't that right? So, from our previous discussion, we have learned that when prices go down, but total revenue goes up, this is a situation when elasticity of demand is greater than 1, right? So, around this price range of 7, 6, 5, and 4, elasticity of demand is greater than 1. We have also learned that when the price is cut, but total revenue is going down, this is the range from 3 to 0, total revenue is going down, is the area where price elasticity of demand is less than 1. It is inelastic. Right? So within the same demand curve, therefore, we will have two regions. One region where elasticity of demand is elastic, and another region where the elasticity of demand is inelastic. You should see that for higher prices, price elasticity of demand were elastic, and for lower prices, the price elasticity of demand were inelastic. When you put that in a graphical perspective, you will see that the total revenue really looks like this. From prices from 8 to about 4, from prices 8 to 4, the quantity is increasing, total revenue is increasing, and reaches maximum and then starts going down. So when you put the demand curve on the upper panel and put the total revenue on the lower panel, you will see that for the higher prices from 7 to 4, cutting prices really increases total revenue because your quantity demanded goes up so much that your total revenue is going up. So the upper part of the demand curve is elastic. Then from 4 to really 0, as you cut prices, your quantity demanded just does go up, but your total revenue starts going down. So the lower part of the demand curve is inelastic. Between elastic and inelastic, there is a point which we will call a unit elastic demand, where percentage change in price and percentage change in quantity demanded are equal. It's a theoretical concept. Unit elasticity is not important. What is important is that unit elasticity really separates the area of elastic region and an elastic region. The most important concept here is that within a same demand curve, one part of the demand curve could be elastic, another part of the demand curve could be inelastic, and between them there is a unit elastic demand. So, elasticity is not constant along a linear demand curve. Even when demand curve is linear, your elasticity really changes from one point of the demand curve to another point. Any question? Does it make sense? Okay. So that's that. The table, this table that you're looking at, I hope that you guys will memorize that, because if you can memorize this table, remember this table perfectly, I can assure you that you will be able to answer at least one question correctly in the upcoming exam. Your exam has only 25 questions, one question is worth about 10 points. So there is a strong incentive to memorize this table. Okay? The next two elasticity concepts that I will be talking about are also related to demand. Okay? Again, I want to start from the mathematical side and then move on to the to the PowerPoint presentation, because I think the PowerPoint presentation kind of talks too much and doesn't really go to the actual point. Okay, so I want to move I really haven't learned how to move from the... Anyway, let me open another slide. The next one that we are going to talk about is our concept number 2, which we will call cross price elasticity of demand. For you, this will be a single page, and this will be the second entry in your sort of summarization. Cross price elasticity of demand, we are going to sort of use a slightly different notation so that we remember what it is. I'm going to write epsilon, which is the measurement of elasticity. I'm going to write A and B, where the cross price elasticity of measurement measures how much what is the change in quantity demanded for good A whenever there is a percentage change in price of good B. So we are looking at two goods, A and B. We really don't know what they are, how they are related. I am thinking about changing the price of good B, and I am looking at how the quantity demanded for good A is changing. I am calculating those two numbers based on your midpoint formula or any kind of formula. I am putting them in the same context, in the same ratio, and I will get this cross price elasticity of demand. Now, this cross price elasticity of demand is a completely different beast. The price elasticity of demand that we calculated before was the same good and the same price. So we were talking about the demand curve, we were moving along the demand curve, and we were calculating the price elasticity of demand. This is a different beast because these are two different goods. A and good B might not be related at all, or they might be. In price elasticity of demand, your sign did not matter because we knew that the sign was always negative. The sign did not matter because the sign was always negative. In your cross price elasticity of demand, your sign can be positive or negative. Let's now try to understand what are the interpretation of those signs. Let's see that the price elasticity of demand is positive. The cross price elasticity of demand is positive. What does it mean? It means, and please listen to the interpretation. The only way this ratio could be positive is if the denominator and the numerator has the same sign. Isn't that right? Which means that if my sign on the denominator is negative, the sign on the numerator is also negative. What does it mean? It means that if I cut price on good A, my quantity demanded for good A will go down. Right? That would mean that when my price of good B goes down, my quantity demanded for good A also goes down. Both the denominator and the numerator negative sign, and overall the cross price elasticity is positive. So what kind of goods are good A and B? Okay. So let's try to understand the complementarity, right? So if the price of good B goes down, the quantity demanded for good A goes down. So if the price of good B goes down, I know that I'm going to buy more of good B. according to law of demand, right? So if I buy more of good B and I'm buying less of good A, what does it mean? It means that they are Coke and Pepsi, right? Because I have just seen the price of Pepsi going down, that's my good B, and if my price of Pepsi is going down, I was buying Coke before, now I am buying Pepsi. So I am switching from A to B. That's how my quantity demanded for good A is going down when the price of B is going down. Are we all clear on this? Does it make sense? So these two goods are clearly substitutes. Was a very quick and correct answer. So the goods are substitute. Okay, now, by the way, you can have the same thought experiment where you could raise the price of B and the quantity demanded for A will go up, meaning that they are also substitutes, right? Meaning that if you raise the price of B and the quantity demanded for A also goes up, you still have a positive sign. The goods are substitutes. The next one is when the goods are negative. When the price elasticity of demand is negative. Now, the cross price elasticity of demand can be negative in two ways. Right? And in both ways, the sign of the denominator and the numerator has to be reversed. Right? If the denominator is positive, the numerator will be negative, or vice versa. So, one way your cross price elasticity of demand can be negative is when you decrease the price of B, the quantity demanded for A goes up. Do we all see that this would generate a negative cross price elasticity of demand? So now let's look at A and B. The price of B is going down, the quantity demanded for good A is going up. What kind of goods are A and B? When the price of B is going down, according to law of demand, we are going to be buying more B. And we see that when we are buying more B, we are also buying more A, which means that A and B are complementary goods. They are like sugar and coffee. The price of sugar went down, I am buying more sugar, at the same time I am buying more coffee. So coffee and sugar, A and B are complementary goods. They are complements. Okay? The next one is called income elasticity of demand. The way we sort of really define income elasticity of demand is just we write epsilon and I. I stands for income. This is a shorthand where income elasticity of demand is calculated as percentage change in quantity demanded whenever there is a change in your income. That's it. Notice that in all the three calculations that we have done, the only thing that really changes is the denominator. Do we all say that? In each case, we are measuring the change in quantity demanded. One for price change, the other one was for the price of another good, and the third one is your income. Just like cross price elasticity of demand, this number can be a positive number or a negative number. Let's start with a situation where the number is positive. The number can be positive when both the denominator and the numerator are of the same sign, right? Let's imagine that we are thinking about a situation where your income is going up, meaning that your denominator is positive. We know that your income elasticity of demand is going to be positive if this is also positive, right? So when my income goes up and my quantity demanded goes up, what kind of good is what kind of good are we talking about here? Do we all see that when my income goes up and my quantity demanded goes up, this is inherently a normal good? This is the good that responds positively with my income. If my income elasticity of demand is negative, which means that if my income increases and I buy less of that good, this is my ramen noodle, right? This is my ramen noodle in the sense that when my income is going up, I am not going to buy any more of that. I'm going to buy something more expensive. So this is going to be an inferior good. Any question? So you can, talk a little bit more, right? So imagine that when your income elasticity of demand is positive, the magnitude now also matters. So if it is greater than 1, so your income elasticity is positive and it is greater than 1. So what kind of goods are we talking about? It is a normal good. Anything else that we can learn about the magnitude of this income elasticity of demand? So the income elasticity of demand is greater than 1. So for increase in my income, my quantity demanded not only rises, but rises really dramatically. What kind of good would you call this?
Normal good.
It is a normal good. It is a normal good because the sign is positive. But now, stay with me for 1 minute. We have 1 minute. Now the magnitude is greater than 1. It's positive and greater than 1. What kind of good is this? It is elastic. It will be a luxury good, and think about it, right? This is the kind of good that you were not buying before, but now as your income is rising, you are buying more of that. If your income elasticity of demand is less than 1, positive but less than 1, this is probably what we call a necessary good. This would be like salt, right? Your income goes up, you really don't buy more salt because you are already buying it before. Thank you very much. I'll see you on Friday.